Pozdravljeni svi skupaj.
Welcome everybody. I wish to present to you the technology of using renewable sources of energy. The source of renewable sources of energy, the biggest one, is actually solar radiation, which through radiation provides indirect energy via water, wind, or photosynthesis as biomass, provides us with the source of heat process, further on heat processes within the Earth, which is called geothermal, and planetary energy expressed as the tide, so the dynamics between the Earth and the Moon. Let us look at the proportion and relationship between renewables and non-renewable sources. On the left, we have renewables, while the green area presents how much energy the sun sends to us on Earth, while final amount represents the total amount of what can be used in the future. From this picture, we can clearly say what considerations are needed in order to obtain sufficient sources for the future. At the bottom, we see the brown circle, which is the factual consumption of energy on planet Earth for our own use. Solar energy is actually solar radiation and can be either used directly with the photovoltaic impact. The second form is active solar technology, whereby the collectors of concentrated solar fields are most known way to use it, and then passive solar energy, which is used to set up materials by using different materials in order to obtain the best heat yield in the given situation. Looking at the technology of photovoltaics, which lately has been most popular also in Slovenia, we see that photovoltaic impact represents the transmutation of electricity of solar radiation into electrical current. We can see a diode at the bottom, and this connection consists of silicious from positive and negative silicious, and when there is less sun radiation, we see that the tension can be used when the consumer switches into the electricity, and there's a current that happens. And then this current is put into different configurations in order to get solar panels or solar cells, which eventually through active elements are linked to the energy grid. The advantage of such photovoltaic system are the possibility of use where other sources of energy are not available, or in distant places, or even up in space when they started to develop fastest. According to experience, the production is biggest and the demand is when the demand is biggest. So there's a possibility for installment in bigger facilities and bigger buildings. We can also use this system as a very small system for just one device, or for bigger systems up to 150 megawatts and more. This is the presentation of less known use of solar energy through concentrated current with heliostatics that are automatically guided. Solar light is sent to the solar pillar with a boiler with certain medium. It can be water, which is heated up to 500 degrees centigrade. This water goes into the turbines, steam turbines, which will be linked to the generator, and then the circle is complete. Why am I mentioning this? There is an advantage because this heat medium can be stored. There's technology of storing heat with different liquidized salts, so that the energy, when there's no longer any solar radiation, such a production plant can still operate with its full production capacity. And the future of energy, or actually the issue of the future, is in demand and supply. The demand of energy does not correspond to supply, and such systems are interesting, especially in, let's say, deserts, where there's lots of sun and they can operate even up to 24 hours a day. This is Mojave Desert presentation in the States. When next year this project will be completed, there are 3 big fields of heliostats, and the total power is 392 megawatts, which will suffice for approximately for 140,000 households. The fact about solar energy is such that with 0.08% of use of solar energy, all the current energy needs can be covered. From the diagram, we can see an increased power obtained from solar radiation. We can see exponential growth. And since we have so much of that source, we can ask whether in 2050 all the energy will be obtained from the sun, and the predictions go in that direction. The next big source of renewables is water energy, which is the 3rd biggest source of electricity in the world. The water energy is produced in hydro plants, where the potential energy transposes it into electricity. Hydroelectric power plants are also the ones who utilize the power of the tide changing. The advantage of hydro electricity is a used and well-checked technology, the long life expectancy, and their use is more than 95% of yield, and the costs are also really low, which means that they enable fast response to the strength of flow, and they can quickly suffice the needs for energy. They also have another advantage, that they have a multipurpose of use of water, which means that if there's a deficiency of water, they can raise the level of the water with a dam, especially in the upper current, and the water sources can therefore also be managed. But unfortunately, the water sources are usually distributed, and they are dependent on topography and the rainfall. This is a cut-through turbine or an electric plant. So we have a river water source, and the mass of water with its kinetic energy travels through the turbine, and then it will run the generator, which is directly linked to the network and transported to the final consumers. You can see that this is a very simple concept, a very simple implementation, which provides a long life expectancy to such a system. It is also interesting to see one of the biggest projects on Yangtze, a Chinese river, and they are about to finish the project of 3 gorges, where the dam is more than 2 kilometers long and 185 meters tall. And this plant produces 25,000 megawatts. But there is a question: how does this huge dam, influence the environment? I believe there was 625,000 square meters of flooding, and 150 villages simply disappeared. The next energy source is wind. Just like water energy, wind has been used for agriculture in the past. Some 1,000 years ago, the wind energy was used for mills, for pumping, for sailing. Nowadays, it is used predominantly for the production of electricity via wind plants. 2.5% of all energy was produced from wind in 2010, and there's a 25% annual growth, which is even more interesting to note. For such a wind turbine plant, we need wind, of course. The consistency of wind is important. The biggest yield is achieved in the fastest speed in 25 meters per second, while it will stop with the speed of 5 meters per second. The same goes for hydroelectric plant. We have a generator. Looking at the system, it's very similar. There's a driving force, which in this case uses wind. There are different possible implementations, one with horizontal axis, where the problem is in the fact that the generator is placed very high, and the second one is rather smaller one, where the horizontal axis enables generator to be placed on the floor, on the ground. Wind plants are also growing rapidly, dependent on considering the power of the wind. Not such huge growth is expected compared to the solar energy. Yet, by 2018, 18% of all energy is to be produced by wind plants. A disturbing factor in wind plants is that the consumption is different from the supply. In theoretical calculations, up to 60% of potential can be used, but usually it's between 20 to 40%. And the advantage is that they don't need much time to be constructed. In Slovenia, we're finally starting with one wind farm, and next month we are expecting to start with the first electricity obtained by wind. 2.5 megawatts will suffice for 1,000 households. Biomass is the next renewable source of energy. Biomass is the result of the process of photosynthesis. Biomass includes also organic waste. Annually, 10 to 11 tons of biomass is used for heating predominantly every year. In more developed states, the percentage is less, up to 14%, while in the developing countries, the consumption of biomass is up to 80% for fuel. The biggest source of biomass is wood and fast-growing plants. The biomass is also used for fuel, and because it has a multi-purpose character due to better storage and better use of gas. As I've mentioned before, biomass is made into energy directly through burning, where heat is the final product. Further on, there are well-known chemical processes turning biomass into biogas. Bioethanol, biodiesel is produced further on. Charcoal, and we can say that biomass is, in a way, a battery storing the solar energy sent to us by the sun, and it can eventually be utilized. It has been really popular to have biogas stations where the technology leads into cogeneration of production of electricity and heating from gas. The advantages of biomass is easy accessibility, independence from the import, especially in Slovenia. By introduction of new technology, It is easy to export this technology. It offers the possibility of new employment. Environmental energy advantage is also important, and a balanced development of agriculture. It is important to note that Slovenia has more than 60% of annual overgrowth in the forest, which is not removed. As I said, biomass can also be turned into biogas and bio-oil for the production of electricity. In order to use this fuel better, there are cogeneration systems with cogeneration production of gas and electricity, whereby gas can be used for the generator, which eventually produces electricity, yet there is heat used as side product in order to heat households. In other words, bigger household units. And the efficiency reaches up to 90%. The next source is geothermal energy. In this case, we actually use it in the sense of the springs of hot water. If these springs are under pressure, they are used for the production of electricity in the same system as we could see at hydro plants, where the turbine is moving, and then with the generator will run the turbine. Otherwise, it is predominantly used for heating of buildings, for, let's say, thermal spa, or for greenhouses. Yet, where we have no hot water sources, the geothermal energy can be used with probe up to the depth of 100 meters. Why? Down to 20 meters, the temperature of the Earth changes dependent on the external influences. Nevertheless, the lower you go, then the temperature levels out, and there's only 3 degrees centigrade growth every 100 meters. So with this geoprobe, we take the energy from the Earth and we use it with the support of heat pump. The heat pump and geoprobe brings us heat from the center, from down under the Earth, and it is a closed down circle filled with gas and mechanical compressor, which pumps up, in other words, increases the pressure on the basis of which we achieve a higher temperature of gas. The gas used in heat pumps is special gas that will obtain this gas form at the 0 degrees centigrade. This is a basic physical law saying that the heat spreads from the warmer body onto the cooler body. And there is another physical law for gas which tells us that if we increase the pressure, then the temperature of the gas will also increase. And this is achieved with this compressor. In this specific example, the temperature of the gas is 2 degrees, and it is pressed. And by pressing it, it increases the energy. Through the expansion valve, it is put into gas again, and when the liquid turns into gas, it cools down instantly and then takes the temperature, the heat from the surrounding area, which is captured with the compressor again, and the cycle is complete. The point is to get more energy than what we invested in pressing. So the proportion is 1:4 in better devices, even up to 5, which means that if we invested 1 kilowatt hour of energy in order to run the compressor, then on the other hand, we get 4 kilowatt hours of energy in the form of heat. These systems are mostly used in households and in facilities for heating. What are the deficiencies of renewable sources? They have relatively low efficiency. Up to 30% is already achieved, yet their operation is not always safe because we depend on the influence from the environment, and these conditions of operation are not a constant. Integration into the existing sources of energy, well, usually the whole infrastructure has to be built, new systems have to be constructed, and the deficiency is also their high price. Predominantly, the renewable energy is very expensive, which means that they are not so accessible to the developing countries, even though biomass there is very accessible as a source. The problem with the high price is resolved often with subsidies, and these subsidies are also enabled in Slovenia. The new support scheme is in place since 2009, yet the production of energy from renewable sources calls for ensuring equal measures compared to the production from classical sources. Different countries have different measures. In Slovenia, it is done on the basis of the energy law with the decrees and regulations of the government. The core objective of using renewables is also the core objective of the energy policy of the European Union. Looking at the National Energy Plan till 2030, we see that there are demands to increase the share of renewable sources of energy, influencing low carbon footprint, and that's very important for all the countries. Thank you for your attention.
I have a question related to drills. What is the problem? Why are there million-euro drills in many municipalities in this northeastern part of Slovenia? They say that they do have geothermal energy, but drills are expensive. And the environmental issues, where there are water sources, water courses, and when we pump water from that, it can be contaminated. The technology as for the costs, I can't tell you what all the problems are in this respect. I cannot really respond to your question. In the Pomurje region, the potential is quite high. The second problem is that is connected with the utilization. Most optimal are the ones with high pressure. So it can be used for the generation of electricity. But the infrastructure is problematic. As for the permits and so on, I do not know where the problem is.